Hey everybody, this is Dr. Maples. We're going to now start talking about probability sampling. Now, with non-probability sampling, we had the issue that maybe we don't know anything or a lot about the population that we're studying. And so we can't be sure that that population, a sample of that population represents the whole population. In other words, it can't be necessarily generalized to everyone in that population. But we do the best we can with non-probability. And then there are times that we actually know a lot of information about a particular group, or maybe we know how many people altogether are in a particular group, and that we have the ability to make sure that we have a very representative sample of them. Now, let's talk about this a little bit, because the first thing that we need to do if we're going to do a probability sample is we need to truly and carefully identify who exactly that we're studying. And that step means that we're going to do something called setting a sampling frame. Now, a sampling frame is kind of like a box, and in this box goes anyone who qualifies to be included in your study. That means that anyone who is in that box, like if you throw their names in there, because you can't throw all the people in there, right? But you could put their names in there. Anyone who's in there could be selected. They all have an equal chance of being selected too. So let's pretend that we're studying EKU parking for students. And I want to make sure that I have a reliable sample that can be generalized across all students. So what I could do is establish a sampling frame that includes all current EKU students. It includes undergraduates, it includes graduates, it includes part-timers and full-timers, it includes distance campuses and online learners, as well as Richmond main campuses. I include everyone in there, and everyone has an equal chance of being involved at this time. That's my sampling frame. Let's pretend that I'm studying student parking amongst a very specific group about sororities and fraternities, for example. So now my sampling frame is going to be all EKU students who are currently a sorority or fraternity member. That means that you have to make sure that you are currently enrolled in EKU in any of the categories I mentioned a moment ago, and you're either in a sorority or a fraternity. That's my sampling frame. I've defined here where I'm going to take my sample from. And now, as I take my sample, it's kind of going to be like I'm going to reach my hand in this box, and I'm going to grab a big group of people that could be included in my study. But let's talk about that a little bit more, because we're going to do that in ways that we make sure, more or less, that we feel confident our sample represents our population, or our slice represents our pizza. I'm just going to bring that joke up in all my lectures from now on. We're going to be talking about completely random things, and I'm just going to be like pizza, slice, population sample. Anyways, I came up with that, by the way. I have to take full credit for it. Others may have come up with it before me too. I don't know. All right, with probability sampling, we got a couple of really cool ways that we can make sure that we know we have a representative sample. Some of these start by knowing exactly how many people are in a group. We don't necessarily know anything about them, but we know how many people are in a group. Let's pretend that my employer asks me to sample what employees want to do for their winter holiday party event. And I know there's 200 people there that are in this employer that I could study. So one way to make sure that we get a statistical sample would be to do what we call a simple random sample. That means I put all 200 names in my box, and maybe I send my survey out to all of them. Or maybe I just reach in and select 50 or 60 of them, and I pull out those names and I send them the survey. But here what I'm doing is I send my survey out, and whoever responds gets included in my sample. It feels kind of like a probability sample, right? Because we know there's 200 people, and we know that people would respond, so that we know a kind of certain percent have responded. At the same time, it still feels a little bit like a non-probability sample, right? Because we don't really know anything about those people, and we're kind of leaving it to chance. Well, that's okay, because this is sort of our weakest version of the probability sample. They'll get better and more detailed as we go along. Now, another good example of the probability sample is we do something called a systemic or systematic random sample. Now, with a systematic random sample or a systemic random sample, it'll just be random which one I say. what we're going to do is we're going to do that same approach that we had a moment ago. We know there's 200 people in our organization, and we're doing a survey about the winter party. We put all 200 names in our box. And now what we're going to do is we're going to select them out, and we're going to set a point that we're going to use to include people. So we set what's called the K, and that's basically what we do to select the interval between cases. And what I can do is I can say, I know there's 200 people that I've put in this box, and I want to interview 30 of them. So what are 20 of them? Keep things easy. So I'm going to interview 20 of the 200 people in this box. And so what I do is I start drawing names out. And so I draw out 9 names, and then the 10th one I keep. That's a person that I'm going to include in my survey. And now I draw more names out, and then the 10th one I keep. Now, by the way, you don't actually have to put all these in a box. Your box could also just be an Excel file or a word list, but you count every 10th person, for example, by setting your K. And again, K, your interval between cases, is set by taking your population, the total number of people, and noting how many people that you plan to survey or interview, and you divide those and you get your number. So in this case, a population of 200 and a sample size of 20 means that my K is 10. And I'm selecting every 10th person to be included. Seems simple, right? We're just using a nice, easy, simple system of picking who would be included. So again, we don't necessarily know this is representative of the group, but we know we have the whole included, and so we're taking a portion of those that we think will be representative. Let's give another example. We can also do what's called stratified sampling. Now, stratified sampling means that we know a little bit about the group, or maybe a lot. With stratified sampling, we're going to make sure that our sample more or less represents the demographic patterns in the group that we're studying, the population. Let's go back to a rock climbing example for this, but let's pretend that I know exactly how many people are in that field. So I know there are 10,000 rock climbers in STEM fields. What I could do is, based on other knowledge that I have, is assume that there's a 60-40 split there, that's 60% male, 40% female. And so what I could do is set up a stratified sample to make sure that 60% of my responses are for males that are in that STEM field of the 10,000 cases in my box, and that 40% are females who are in STEM fields of my 10,000 cases in the box. Let's go back to the holiday party for another example. So we have 200 people there, and maybe we know that 60% of our colleagues are male and 40% of our colleagues are female. So we could ensure, again, that 60% of the people are selected are male and 40% are female. How do we do that? Well, there's a couple of ways. One easy way could be from the start, when we're setting up our sampling frame, we could split our boxes into a male box and a female box, and what we could do is choose cases out of those two. Another one could be that we take the first 60% of male cases, and we take the first 40% of female cases. Let me explain that better. Let's pretend that I get exactly 100 people respond to my survey, and what I go through is I take the 60% of the males and 40% of the females, so I make sure that I've got a sample that makes sense, that represents the people that I'm trying to sample. So again, we know a little bit more about it, so it's better than our previous examples. With a stratified sample, we know just a little bit more. Now, we're going to go to our last one. This one is both uncommon and a little tricky. Let's pretend that we know a fair amount about this particular group, but we also know that there are subgroups within it. Let's pretend that I know there are 10,000 rock climbers who are in the STEM professions. To try to talk to all of them or to even sample all of them might not be possible. But maybe I know there's smaller groups within them, such as a local climbing organization. Well, I could try to sample a couple of those local climbing organizations in one area and try to have that represent the whole sample. Likewise, I could do that with my office example. Let's pretend that I have my 200 people, but maybe there's some subgroupings. So there's accounting, and then there's bills collectible, or collecting, we'll say. So there's accounting, there's collecting, and there's management. And maybe I could try to cluster in and get some of those groups, maybe just get the people from collections, because they're easier to access, and maybe I can't talk to the others as easily, and try and get information from them and hope that I could generalize that to the whole population. Probability sampling in terms of cluster sampling, I've never actually had to use that in my work. Again, most of my work is non-probability samples because it's kind of new, innovative populations that haven't been studied. Cluster sampling sometimes can come up when you're dealing with trying to study an entire state and you maybe study a cluster of counties. But beyond that, cluster sampling doesn't come up a lot. Instead, you're far more likely to choose stratified or one of the previous examples. All right, that wraps it up for talking about our non-probability and probability samples. In the last lecture of our sampling series, we're going to talk about some of the basic problems that you experience and also where we go from here for the rest of this course. All right, if you got questions, you know where to find me. We'll talk soon. See ya.